first looked at how do we see whether the production function exhibits decreasing returns to capital, how do we check whether it's characterized by constant returns to scale, and now we want to see that can we write it in terms of can we write it in per worker form. Now the idea is this, we can write a production function in per worker term. I write output per worker as a function of capital per worker only if the production function is characterized by constant returns to scale. And as we showed in part 2, this production function is characterized by constant returns to scale. So we can write this particular production function in per worker form. So let's do that now. So the idea is this. So we are doing part C. Since the production function satisfies constant returns to scale, we showed this in part 2. We can write it in per worker form, satisfies constant returns to scale. We can rewrite the production function in per worker form. If it did not satisfy constant returns to scale, we could not write it in per worker form. We can rewrite the production function in per worker form. Now the way to do it is very simple. We write the production function in per worker form. So now our production function is given to us as y is equal to k 1 by 2 n 1 by 2. To get it in per worker form, what we'll do is we'll divide both sides by n. So when we divide both sides by n, this becomes y by n is equal to k 1 by 2 n 1 by 2 divided by n. So now what we do is let's combine like terms, which I mean is on the right hand side, we can just take the n down and write this as n 1 by 2. Why can we do this? This is the root of indices, right? Okay, when we take this n power 1 by 2 down, this becomes n power 1 times n minus 1 by 2 in the denominator, and then when we have like bases, we can add their powers. So then it becomes n power 1 minus 1 by 2 is 1 by 2. So then we have this. Now what we can do is we can further simplify this as y by n is equal to k by n 1 by 2. Here again we're using an indices rule, if you recall, that if we have AM by BM, when we have a common power over for a ratio, we can like take that power common. You can think about it like this, right? So when you're taking the same power of the two components of a ratio, we can write basically it as the power of the entire ratio. So AM by BM is A by B power M. So then we can further so now let's just write, now let small y, now let's just do some notation, like we can just define small y to be output per worker and small k to be capital per worker. So then we have y is small y, which is output per worker, is equal to small k power 1 by 2. So we have shown here that output per worker is a function of capital per worker. Output per worker is a function of capital per worker here. So in this way, we can write a production function in per worker form given that it satisfies constant returns to scale.